Hello, everyone. I want to start with a question. How many of you have ever heard complaints that your app is slow? All right. And how many of you immediately knew what to do about it? All right. So this is exactly what we're here to talk about today. I'm Stella Gaitani. I'm the product manager for Firebase Performance Monitoring.
I'm Christina Holland. I work on the Firebase JS core team.
And I'm Kashefian, and I'm a software engineer on Firebase.
So let's talk about slow. What do we mean by an app being slow? Well, there are two perspectives. From our perspective, as web developers, when we think about an app being slow, we think about many different things. We think about page load times, we think about runtime slowness. However, from our user's perspective, this is all the same. The app is slow. And a slow app means that our users are sad because they're having a frustrating experience on our site. So we want our users to be happy. And what do? We start to think about performance. And the first thing that comes to mind is we're starting to look for things to cut. And this is a great place to start. Because more often than not, there are things that might not be serving us or our users and are slowing our site down. However, at some point, we get to this trade-off. We have a feature that is helpful, adds value to our users, but it is impacting our performance. We might at that point say, well, it is what it is. This is the functionality I want to deliver to my users, so I have to take the performance hit. However, we think there is a better way. What if, instead of thinking about performance as this trade-off between the features we want to have and the speed, we think about performance as a game of Tetris, where we think about how to line up our features in the most optimal way to minimize their impact on our site's performance. So how do we do that? The first step is to understand what our users are experiencing. And this is where Firebase Performance Monitoring comes in. Firebase Performance Monitoring will tell you what your users are actually experiencing when they're coming on your site. Then, we will think about how to only download the bare minimum of code that we need to put data on the page, and then bring the rest later as we need it. Finally, we will close the loop, and we will check how the changes that we're making are impacting our site's performance. Are things looking like they're getting better? Is it the same? Did we make anything worse? We want to show how to do all of this in action. And we have prepared the demo to show you exactly that. I'm going to turn it over to Christina, who's going to walk us through our demo app. Christina?
Thanks, Stella. Can we get the demo up? So here we have a simple stock app. It has a list of popular stocks that update every minute for, say, the casual day trader. For this demo, I just loaded a bunch of old stock data into Firestore. So it's just replaying August 28th over and over again. So don't use this data to make any stock trading decisions. So we have a home page that anyone can see without logging in that has the most popular stocks. And maybe in the future, you add a feature where you let people log in, and they can create their own custom lists. But this home page is open to the public. So we've got our app. We put it up. And we get lots of hits, which is great. And like a responsible developer, we're going to check in with our channels for user feedback. And we're going to ask the users, what do you think?
Well, I played around with this app, and I have to say, the app feels slow.
So the developer's going to want to ask, slow how? Is it slow initial page load and rendering? Is it slow data fetching? Or does the UI feel sluggish and unresponsive?
I don't know, it just feels a bit slow. So can you please fix it?
So that's frustrating feedback, because it runs fast enough on my machine. So how can I figure out what the users are seeing? This is where Firebase Performance Monitoring comes in. Stella?
So let's see what Firebase Performance Monitoring can do for us. And let's go back to the slides now. Excellent. So Firebase Performance Monitoring is a real user monitoring tool. What this means is that it shows you how your users are actually experiencing your app out in the wild. You have users coming on your site from different devices, from different countries, on different connection speed. Their experience on your site might be very different based on those conditions. So the way that Fireperf helps you understand what is going on is by showing you the full distribution. Instead of just providing you with one data point, let's say the median or the 95th percentile, which is very important because we want to understand how our app is doing at its worst. But it also shows you the full distribution of, let's say, the load times for your users. So you can see how many of your users are on the happy side of the curve. That means they have fast load times and a good experience on your side. And how many of your users are on the other side. They're on the long tail of users who are experiencing long load times, are frustrated, and these are the users that you want to be really thinking about. So far I talked about page load time, and this is a metric that is very common when we're thinking about performance. But Fireperf also gives you additional user-centered metrics. The reason is that page load time by itself can be a bit misleading, because, for example, you can see how long it takes for your full page to load, but if your users are seeing useful information in the meantime, they might not be noticing any delays. So let's see what Fireperf shows you. It gives you some metrics such as the first contentful paint, which is the time that it takes for the first content to show up on your page. And it also shows you the first input delay, which is the time that it takes for your site to respond to the first action that your users take on your site. So these metrics, in addition to, of course, page load time, will give you a more complete picture about what your users are actually experiencing. So now, I want to turn it over to Ali, who's going to first tell us how to integrate Firebase Performance Monitoring to our app, and then he will show us what the Fireperf console can tell us about the demo app, so we can understand what is going on there.
Thank you, Stella. Integrating with Firebase Performance Monitoring can be as easy as dropping a few lines of code in the HTML page, or if you have a build system in place, you can download and install the NPM package. Now, let's go to the console and see what the developer of the stock app sees. Out of the box, Firebase Performance captures metrics related to the page load of our application. This is very helpful to find out if any of the pages are running actually a little bit slow. Also, as we will see later, we capture all the network calls made from the web app, which is helpful in finding out if any of those calls are taking too long. So let's start by going to the page load table and check out the main page of the application. This is the URL of my app. ** means all pages under this pattern. We currently only have one page. So let's go here. And this is the full distribution of all the metrics associated with the page load. Let's check out a few of them. For example, first contentful paint, the median is over 3 seconds, and the 95th percentile is a little bit shy of 5. The load event end, which is basically the time it takes the page to load all the assets, the median is around 3 seconds, but there's a long tail of users who experience much longer load times, as high as around 30-something seconds. All of this is good to know, but what we are really interested in is to find out how long it takes the users to start seeing the stock data, right? And this is very specific to this app. In other apps, it could be other custom metrics that we are interested in. So can we customize Fireperf to capture such custom metrics? Yes. We can use custom traces and custom metrics to capture whatever we are interested in. In this case, as I said, we are interested in the duration between the navigation start until we load the initial stock data. Let's call it initial data load time. Once the developer of the stock app applies the necessary modifications, the initial data load time will start showing up in the durations table. Let's take a look. This is the full view of the data, and this is the distribution. As you can see, the median is around 4.4 seconds, but there is a lot of users who experience much longer load times, up to 38 seconds, which is a long time. How can we find more information about these users? One of the features of Firebase Performance is that it allows you to dissect the data by various attributes, such as browser, country, so on and so forth. This is very helpful if you want to find out if any segment of the users are experiencing the app differently. For example, if my app does not render well on a certain browser, or if my page loads takes a long time to load in a certain country or certain region. A particularly interesting one is the effective connection type. Effective connection type allows us to see if there is any difference between the experience of users on the faster connections with the slower ones. Let's see what we can learn here. First of all, the possible values are 4G, 3G, 2G, and slow 2G. 4G capturing all the users on faster networks. And these all come directly from the Navigator API of the browser. It seems like around 60% of my users are on faster networks, which basically means that 40% of them are not. And the users on faster networks are only taking a few seconds to start seeing the data, but the users on slower networks are taking much, much longer. This must be painful. What could be the reason? Usually, when there is a significant difference between the experience of users on faster or slower networks, the culprit is a network call which is taking too long. So let's see if this is the case in here. We can do that by going to the Network tab. And as you can see, we capture all the networks made from the web app. So let's first filter by the page that we are interested in. We can change the duration. And I'm going to change the sort to response time, so the longest call appears on the top. The longest one happens to be firebase.bundle.js. Sounds familiar? It's actually the package which includes all the code from Firebase JS SDK. So here, the response time, the median is 1.75 seconds, but there is a long tail of users who take up to 30 seconds to load this package. And this makes sense because the payload size is 210 kilobytes. It's a large package. It must be painful to download this package on slower connections. Let's confirm that by going to the full data view of response time, see the breakdown by effective connection type, and yes, users on slow connections are taking a very long time to download this. So we are downloading a large package, and this is affecting the experience of our users on slower connections. Now, equipped with this insight, let's see how we can fix it.
So it looks like we need to cut some code. The good news is that cutting code doesn't necessarily mean sacrificing functionality. The first thing we should check is if there is some code we're sending down to the user that we don't need to be. So how might that happen? If we open up the console, you might see this warning message that says we should only be importing the Firebase components we need. So that's a good place to start. If we take a look at the code, the first line is import Firebase from Firebase. Pretty standard. And I'm going to tell you ahead of time, this is where the problem is. But let's step through the app and just see how it works. So after we import Firebase, the next step is to subscribe to Firestore. And then when we get the Firestore data back, we'll immediately render it for the user. What the code looks like is that after importing Firebase, we initialize the app. And then just this one line gets performance started. That's all you need. Then we'll subscribe to Firestore. Once the data comes back, we'll render the page with it. Just so you know, there's nothing magical inside the subscribe to Firestore function. It's a simple subscription to a Firestore collection called current using onSnapshot. Every time a snapshot comes back, we format and render it. The first time we get some data, we will log this initial data load time custom metric. That's how we got it into the dashboard. So the first line is the problem because we are importing all of Firebase, including components such as auth and storage, which we're not even using in this app. Instead, let's just import the components we need. So we're going to import the Firebase core app, which is very small, and then Firestore, of course, and then performance to measure what we're doing. So having made just that one change from importing Firebase to importing these components, let's see how it performs. I'm going to put up a demo of the two apps side by side. On the left is our original app, and on the right is importing just the components we need. And this is throttled to 3G, because that's the users that are having problems. And it looks like we've got a speed improvement. So that's pretty encouraging. But again, works on my machine is not good enough. So we need to get this out to the users, and then we're going to check the dashboard again to see how it's performing for them.
Let's take another look at firebase.bundle.js and how it was affected by the changes that we made. So here it is. Let's take a closer look. The median is down to around 1 second, which is good. But still, we have a long tail of users who are experiencing some delay. And the 95th percentile is over 16 seconds. Improved, but still not that good. And here is the payload size. We have cut our payload size to less than half. Great. Let's see how this is affecting the initial data load. We go back to the On-Device tab, and this is initial data load time. This is the time view of our data. The x-axis is time. The bottom of the blue area is the 5th percentile, and the top is the 95th percentile. The dark blue line is the median. Pay attention to how we shaved off the 95th percentile from 30-something seconds to 20-something seconds. This is when we made the change. So this is great, a lot of improvement. Let's focus on the latest version of the app. We can see that the median is around 3 seconds, but the long tail is still here, and it's taking some of our users more than 23 seconds to start seeing the data. So we made improvement, but some of our users are still suffering, which begs the question, can we do even better?
So yes, I think we can do better for our users. So if the first easy win is to cut out any large chunks of code that you're not using, the second is to see if there's any large chunks of code we can bring in later. As you can see, we cut the bundle size down by a half, which is great. What if we could effectively cut it down to 0? What if we could get them their whole page before we have downloaded any of the Firebase libraries? So you might be thinking, OK, lazy loading, I know how that works. We're going to render as much of the page as we can before we get the data. And where we don't have data, we're going to put placeholders and spinners. But no, because from the user's point of view, a page that has spinners on it is a page that is not done. Let's do better for them. Let's get them a complete page with all the stock data before we've downloaded any of the Firebase libraries. Is that even possible? Well, I don't know how many of you know this, but Firestore has a REST API. That means we can hit a REST endpoint with HTTP GET and get JSON data directly from Firestore. So what's that look like? Here's a typical URL that will hit the Firestore REST endpoint and get data from a collection named current. That's our stock data. So if I was to curl, I get the JSON data for all our stocks. So I can use that and render the page. But this is a stock app, so users are going to want their real-time updates. And the Firestore library makes that really convenient, and it's a lot more cumbersome with just REST. So is there some way we can get the best of both worlds? Yeah, so we're going to look at our game plan. We're going to first fetch the REST data very fast, render the data immediately, so now the user has a complete page, and they're happily looking at their stocks, and only then will we dynamically import Firebase components in the background. And once they've downloaded, we'll subscribe to Firestore. And they'll have their real-time updates before even the first minute refresh is up. So what that looks like is, let's review. We originally imported all of Firebase. Then we imported just the components we need. Now we're importing nothing from the Firebase library initially. Instead, we're going to put that URL in a variable. And our very first step will be to use the native browser fetch to fetch from that URL. We'll get JSON data, format it, and we've got the data. So we can log the initial data load time metric, render the page. So when we have a happy user looking at a complete page, and only now will we dynamically import Firebase. Once that's downloaded, we'll initialize the app, get performance started, subscribe to Firebase, and swap in that live data without the user even knowing. So there's nothing magical about this dynamic Firebase import. It is just 3 import statements to import those 3 libraries we imported earlier, and then returns a promise. Imports not supported in older browsers, so if you're supporting older browsers, know that you will need to use a polyfill. So we've got that plan going. Let's see how it plays out. I'm going to demo 3 apps now. On the left is going to be our original. In the middle is going to be just the components we need. And on the right is going to be our REST and dynamic import, which finished loading before I even explained what it was. So that's pretty fast. So that's a pretty good progression. I'm going to be pretty excited about that. But again, I just checked this on my local machine. So that's not good enough, right? We've got to get it out to the users, and we're going to check the Firebase Performance dashboard to see if they're seeing this great improvement.
All right, thank you, Christina. Now, let's check out the initial data load time again. So in the first set of modifications, we shaved off the 95th percentile from 30-something seconds to 20-something seconds. With our recent changes, the 95th percentile is around a few seconds only. Let's focus on the latest version. All right. So the distribution shows us that the median is around 1.5 seconds, and the 95th percentile is less than 5 seconds, which means that for the vast majority of our users, the app and the data loads in a few seconds, which means that the vast majority of our users are happy ones.
So that's a pretty great outcome. So you've seen some tips to make your web app a little faster. Can we do even better? Like, for example, we provide you with the ability to import just the components you need, such as auth and Firestore, database, and storage. What if we could modularize even farther, and we could provide you with just the methods you need? For example, on a lot of home pages, you just want to know if a user's logged in or not. So you just need get current user without bringing in the rest of the auth library. Is that something we can do? That is a great suggestion. Thanks for suggesting it. And we are definitely looking into how we can get something like that to you. So keep an eye out.
Awesome. Thank you so much, Ali and Christina, for making our demo app users very happy. So our key takeaway from today is how you can use Firebase Performance Monitoring to understand what your user's experience is like, and then start thinking about how you can only download the bare minimum to get your data on the page, and then bring in the rest later as you need it. Our mission here at Firebase is to help all of you succeed by providing you with the best tools to help you build amazing user experiences. We hope today you got some helpful tips on how to speed up your apps using Firebase. This is our GitHub repo if you want to check out the code that we used for this demo. And we will be all hanging out at the Ask Firebase booth after if you have any questions. Thank you, and have a good night.